Hello everyone, and welcome. In this video, we'll be diving into the world of Power BI, focusing specifically on one of the most important concepts, basic DAX. This session is brought to you by ZoomInData, your space for learning business intelligence and data analytics. So, let's get started and understand how Power BI connects to different data sources and why this process is so essential in today's data-driven world. First question: what is DAX? DAX, Data Analysis Expressions, is a formula language used in Power BI, Power Pivot, and analysis services to create custom calculations. It allows you to perform calculations on data from multiple tables and perform advanced data modeling. DAX is designed to work with relational data and enables dynamic calculations based on context. It supports both simple aggregations like sum and complex calculations involving filter and row context. Second question: explain DAX purpose in Power BI. The primary purpose of DAX in Power BI is to create calculated columns, measures, and KPIs for data analysis and reporting. It helps transform raw data into meaningful insights by performing mathematical, statistical, and logical operations. DAX allows for dynamic calculations that respond to user interactions such as slices, filters, or visuals. It enhances Power BI's analytical capabilities by enabling time intelligence functions and hierarchical calculations. Third question: what are the difference between calculated columns, measures, and Excel formulas? Calculated columns are computed row by row and stored in the table, while measures are dynamic calculations evaluated based on the filter context. Measures are not stored physically in the data model, making them more memory efficient for large datasets. Excel formulas work only on a single table or sheet and are static unless manually updated, whereas DAX works across multiple related tables dynamically. DAX provides advanced functions like calculate, RELATED, and time intelligence, which are not available in standard Excel formulas. Fourth question: when should you use a calculated column versus a measure, and how does each impact performance in Power BI? Calculated columns should be used when you need a value calculated for each row in a table and stored physically in the data model. Measures should be used for dynamic aggregations that respond to filters, slices, and visuals without consuming extra storage. Using too many calculated columns in large datasets can increase memory usage and reduce performance, making the model slower. Measures are more efficient for summaries, KPIs, and interactive reporting since they are computed on the fly. Fifth question: can you provide a practical example comparing total sales calculated per row using a calculated column versus total sales overall using a measure? Let's understand the difference between a calculated column and a measure in Power BI with a simple example. A calculated column works at the row level. For instance, imagine a column called total sales inside the sales table. It is calculated using the formula, quantity multiplied by unit price. This value is stored for each row and stays the same, even if filters or slices are applied in the report. On the other hand, a measure works dynamically. A measure for total sales might use the formula, sum of the total sales column. Unlike a calculated column, a measure recalculates itself every time filters, slices, or visuals change. This means the result is always updated based on the current filter context. So in summary, a calculated column is used for row-level calculations, while a measure is used for dynamic aggregations that change with the report's filter context. Sixth question. What is row context in Power BI, and how does it apply in calculated columns? Row context occurs when a calculation is evaluated one row at a time inside a table. This is most commonly seen in calculated columns, where DAX automatically knows which row is currently being processed. Because of row context, a formula can easily reference other columns from the same row to perform its calculation. For example, in a sales table, a calculated column like total sales equals quantity multiplied by unit price uses row context to compute the total sales for each individual order. So simply put, row context is what allows Power BI to perform calculations row by row. Seventh question. What is filter context in Power BI, and how does it apply in measures? Filter context occurs when a calculation considers filters applied by slices, visuals, or other DAX functions. It is primarily used in measures, where the result depends on the subset of data currently visible. Filter context dynamically changes the result based on the selection in reports. For example, a measure like total sales equals the sum of the total sales column will only add up the sales for the selected region, customer, or time period shown in the report. Eighth question. Can you provide an example comparing total sales per customer calculated using a measure versus a calculated column? Using a calculated column, total sales per customer could be computed row by row and stored physically in the table. Using a measure, total sales per customer is dynamically calculated. Total sales equals the sum of the total sales column, reflecting filters like customer or region. The calculated column is static and does not respond to slices, whereas the measure updates automatically with filter changes. This comparison demonstrates the difference between row-level calculations, column, and context-sensitive calculations, measure. Ninth question. What is the purpose of the calculate function in Power BI? Calculate is a powerful DAX function used to change or modify the filter context of a calculation. It allows you to apply specific filters or conditions to a measure while keeping other aggregations dynamic. Calculate is essential for creating advanced measures and KPIs in Power BI reports. It works with multiple filters and DAX functions like all, filter, or values, to customize calculations. 10th question. How does calculate modify the filter context of a calculation? Calculate overrides the existing filter context or adds additional filters for the calculation. It can narrow down or expand the data subset used for a measure based on the given conditions. Calculate allows combining multiple filters using logical operators like AND or OR. It enables dynamic, context-aware measures that respond to slices and visuals in the report. 11th question. Can you provide a practical example using Calculate to compute total sales for a specific region? For example, consider a measure like total sales East equals calculate of the sum of total sales, with region set to East. This calculation returns the total sales only for the East region. This measure ignores other regions while still responding to filters like time or product category. Unlike a simple sum, Calculate can combine multiple conditions for complex business scenarios. It demonstrates the dynamic modification of filter context, which is essential for interactive dashboards. 12th question. What is the purpose of the related function, and how is it used in DAX? Related is used to retrieve a single value from a related table based on an existing relationship in the data model. It works primarily in calculated columns to bring data from another table into the current table. Related requires a one-to-many relationship, where the current table is on the many side. Here's an example of how the related function works in Power BI. Imagine a sales table that needs to display the product category for each item sold. Using a calculated column like product category equals related of product category, Power BI looks up the matching product in the product table and brings back its category. 13th question. What is the purpose of the related table function, and how does it differ from related? Related table returns all related rows from another table instead of a single value. It is typically used in measures or calculated columns when aggregating data across related rows. While related fetches one value, related table provides a table of values to perform functions like count rows or sum x. Now let's look at an example using sum x with related table in Power BI. Consider a measure like total sales equals sum x over the related sales table, returning the total sales column. This calculation is often used at the product level. What happens here is simple. For each product, Power BI retrieves all the related sales records and then sums their total sales values. This makes sum x with related table a powerful way to calculate totals across related rows, especially when working with product level or customer level summaries. 14th question. Can you provide a practical example showing the difference between related and related table? Let's understand the difference between related and related table in Power BI. Using related, Power BI performs a row-level lookup. For example, in the sales table, a column like product category equals related of product category brings in one category for each product row. It retrieves a single value from the related table. Using related table, Power BI retrieves multiple related rows. For instance, in the product table, a measure like total sales equals sum x over the related sales table, summing the total sales column calculates all sales for each product across many sales rows. So in simple terms, related is for bringing in one value per row, and related table is for aggregating many related rows. Understanding this difference is essential for building accurate measures and hierarchical calculations in Power BI. 15th question. What are time intelligence functions in Power BI, and why are they used? Time intelligence functions are DAX functions used to perform calculations based on dates, such as year-to-date, month-over-month, or period comparisons. They simplify calculations that involve cumulative totals, growth rates, or comparisons across time periods. Time intelligence functions require a proper date or calendar table in the data model for accurate results. They help create dynamic measures that update automatically when users interact with date slices or filters. 16th question. How does total YTD work, and when would you use it? Total YTD calculates the year-to-date total for a given measure, summing all values from the beginning of the year to the selected date. Here's an example of how the total YTD function works in Power BI. A measure like sales year-to-date equals total YTD of the sum of total sales, using the date column calculates all sales from January 1st up to the selected date in the report. This makes total YTD a powerful time intelligence function, allowing dashboards to automatically track performance across the year based on the user's current date selection. It is useful for tracking cumulative performance within a fiscal or calendar year. Total YTD automatically respects filters on months, quarters, or other dimensions in the report. 17th question. How does same period last year function help in year-over-year comparisons? Same period last year returns the corresponding period in the previous year for the selected dates. Here's an example of how same period last year works in Power BI. A measure like sales last year equals calculate of the sum of total sales, using same period last year on the date column returns the sales for the same period in the previous year. This makes it easy to compare current performance with last year's results, which is essential for trend analysis and year-over-year reporting. It is commonly used to compute year-over-year growth or trends. The function dynamically adjusts to filters applied in visuals like months or quarters. 18th question. Can you explain date add and provide an example of its usage? Date add shifts a date column by a specified number of days, months, quarters, or years. Here's an example of how date add is used to calculate previous month sales in Power BI. A measure like sales previous month equals calculate of the sum of total sales, using date add to shift the date column back by 1 month returns the total sales for the previous month. This helps compare month-to-month performance and is a key part of building time-based insights and trend analysis in Power BI. It is useful for comparing current and past periods or creating moving totals. Date add maintains the filter context and works well with other time intelligence functions. 19th question. What is the selected value function, and why is it used in Power BI? Selected value returns the currently selected value from a column when exactly one value is chosen. It allows creation of dynamic calculations where the output changes based on slicer or filter selection. It simplifies logic because it replaces more complex if or has one value conditions. It is mainly used in interactive dashboards where users need to choose what metric or dimension to view. 20th question. How does selected value help create dynamic or user-driven measures? Selected value enables users to control which measure, field, or calculation should be displayed. It allows the report to react instantly to slicer selections, making visuals more flexible. You can use it inside Switch to change formulas depending on user input. This helps build dashboards where the same visual shows sales, profit, quantity, or margin based on user choice. 21st question. Can you explain a practical example of using selected value to switch between different metrics? Here's an example of creating a dynamic measure using switch in Power BI. Imagine a slicer with 3 options: sales, profit, and quantity. Based on the user's selection, Power BI can calculate different metrics using a single measure. A measure like dynamic metric equals switch of the selected value from the metric table. If the user selects sales, it returns the sum of sales amount. If profit is selected, it returns the sum of profit. And if quantity is selected, it returns the sum of quantity. This approach makes reports interactive and flexible, allowing users to switch between metrics without needing multiple visuals or separate measures. This lets one visual show different metrics without duplicating charts. Users get a clean, interactive design where one selection changes the entire calculation. 22nd question. How does selected value behave when no value or multiple values are selected? Selected value returns a default value if provided, when zero or multiple selections exist. Here's an example of how selected value works in Power BI if a slicer is connected to the metric column. The function, selected value of metric measure, with a default of sales will return the selected value when the user makes a choice. But if nothing is selected, it automatically returns the default value, which in this case is sales. This makes selected value very useful for creating dynamic measures and ensuring the report always behaves predictably. When multiple values are selected and no default is provided, it returns blank. This behavior prevents errors and ensures clean output in visuals. 23rd question. How is the top N function used to return the top items based on a measure? Top N returns a specified number of top or bottom rows from a table based on an expression. It is typically used inside Calculate to filter data for dynamic KPIs or visuals. Example: getting the top 5 customers by total sales for further aggregation. Top N is useful when you want only a subset of highest performing values to feed into another calculation. 24th question. How does the rank X function work for ranking rows in a table? Rank X assigns a numeric rank to each row in a table based on a measure or expression. It evaluates each row and compares values to determine rank, such as highest sales is equal to rank 1. It supports ascending or descending order and handles ties based on ranking options. Rank X is ideal for scoring, leaderboard reports, or identifying top performers within categories. 25th question. Can you give a practical example of finding the top 5 products by sales using top N? Here's an example of how the top N function is used in Power BI. A calculation like top 5 products equals top N of 5 from the products table, ordered by total sales in descending order, returns the 5 products with the highest sales. Top N is very useful for ranking, highlighting best performers, and creating focused insights in dashboards. Asterisk. This table can then be used inside Calculate to sum sales only for those top 5 products. The result can be placed in a table visual to show only the highest selling items. This approach helps focus dashboards on key performing products without clutter. 26th question. What is the difference between top N and rank X in Power BI? Top N returns a filtered table of top, bottom rows, while rank X returns a numeric rank for each item. Top N is used when you want only the top items, whereas rank X ranks everything for comparison. Rank X is more flexible for creating leaderboard. Hello everyone, and what is the difference between top N and rank X in Power BI? Top N returns a filtered table of top, bottom rows, while rank X returns a numeric rank for each item. Top N is used when you want only the top items, whereas rank X ranks everything for comparison. Rank X is more flexible for creating leaderboards, but top N is simpler for selecting a limited subset. Top N works on tables. Rank X works on individual rows and produces a number for each row. 27th question. What is the earlier function in DAX, and how does it work with nested row context in calculated columns? Earlier is a DAX function used to access the value of a column from an outer row context when multiple row contexts exist. It is mainly used within calculated columns where functions like filter, add columns, or SumX create an inner row context, requiring reference to the original row. Earlier allows you to compare the current row with other rows in the table by retrieving values from the previous evaluation level. It enables row-by-row logic in nested loops, helping implement ranking, conditional comparisons, or iterative calculations within the same table. 28th question. Can you explain a practical example where earlier is required for row comparisons, and why modern DAX prefers variables or rank X instead of earlier? A practical example is creating a manual rank column, comparing each row's sales value to all other rows using a filter function and referencing the outer row's value with earlier. Here's an example of how ranking can be done using earlier in Power BI. A calculated column like rank equals the count of rows in the sales table where total sales is greater than the total sales of the current row, plus 1 essentially compares each row with all other rows. By doing this, Power BI assigns a rank based on total sales, with the highest sales getting rank 1. This method shows how earlier helps create row-by-row comparisons inside calculated columns. Asterisk. Modern DAX prefers using var, rank X, and iterators because they're easier to read, provide clearer logic, and offer better performance than earlier. Earlier is now used mostly in older DAX codebases, as newer functions replace it with more efficient and understandable alternatives. 29th question. What is the purpose of the all function in DAX, and how does it modify filter context? All removes all filters from the specified table or column, allowing calculations to consider the entire dataset. It is commonly used in calculations like percent of total or ranking across all categories. All overrides slices, visual filters, and row context converted to filter context. Here's an example of how the all function works in Power BI. A measure like total sales all equals calculate of the sum of amount, using all on the sales table returns the total sales with all filters removed. No matter what slices or selections are applied in the report, this measure shows the overall total. This makes all useful for comparisons such as percent of total or benchmarking against global numbers. 30th question. How does all except differ from all, and when do you use it? All except removes all filters except those on specified columns, keeping only selected columns filtered. It is used when you want totals or rankings that respect some dimension like product or region. For example, you can remove all filters except customer to keep customer level grouping intact. It provides more control compared to all, which clears everything. 31st question. What does remove filters do, and how is it different from all? Remove filters clears filters like all, but it is more modern, easier to read, and works consistently across complex filter scenarios. It only removes filters without impacting row context or relationships, while all can also change table shape in some cases. Remove filters is preferred in modern DAX because it avoids ambiguity and simplifies calculations. Here's an example of how remove filters works in Power BI. A measure like calculate total sales with remove filters on the date table removes only the date-related filters while keeping all other filters in place. This means the measure ignores selections like year or month, but still respects filters such as product category or region. It's a powerful way to control exactly which filters should affect a calculation. 32nd question. What are some practical examples of using calculate with more than one filter? Here are a few examples that show how calculate can apply multiple filters at the same time in Power BI. To get sales for the year 2024 and the category electronics, a measure like sales 2024 electronics equals calculate of total sales, with year set to 2024 and category set to electronics returns only those filtered results. For profit in a specific region and product type, a measure such as profit filtered equals calculate of total profit, with region set to South and product type set to premium returns profit under both conditions. And to calculate customer sales without discounts, a measure like no discount sales equals calculate of total sales, where the discount is 0 filters out all discounted transactions. These examples show how calculate can combine multiple filtering rules to create precise and powerful business insights. 33rd question. How does calculate behave differently when using filter arguments like filter, ALL, or values? Using filter allows applying row-level logic, enabling complex comparisons not possible with simple filter conditions. Using all removes filters, allowing calculate to compute results such as % of total or grand totals. Using values restricts evaluations to unique values, often used in dynamic calculations like selected customer or month. Calculate interprets these helper functions to adjust filter context in highly flexible ways. Thank you for watching this session. If you have any questions, you are welcome to contact ZoomInData through our website, email, or phone. We're always here to support your learning journey. See you in the next video.